Number 7 and 8, we're looking at, here we go. We're looking at 5, 4, 1, and we're looking at number 7 and 8. So to start, number 7 is just that it says make an equilateral triangle, okay? Inscribed in circle Y with radius equal to AB, okay? So the key to this is you go to your screen, you arbitrarily open it up to the distance between A and B, and our AB distance is this. You can't see it, but there's a point there. So I just make an arc, small arc, to show that this is AB. Okay. So however you get the measurement of AB onto your page is up to you. If you don't have the workbook, then you can measure it off the screen. But all we have to do is make an equilateral triangle with circle Y, radius equal to AB. So here, that'll work. Circle Y. Now I go and I measure AB, still have it. So I'm going to go and start at Y, and nope, I'm going to go over my instructions, and that is unacceptable. That's the only guideline. Try to make it so that you can't, or that you don't go over the things on the page that are helpful and important, like the instructions. Oh, I just lost it. Okay, bring it back. We can do it. We could salvage it. Boom, got it. Okay. So the first step is making a hexagon. Oh, thanks, Kimberly. So it doesn't matter, right? Because actually it will matter in this case. So that is good. Okay. So to make a hexagon, it's a similar process as making a equilateral triangle, but we are going to use the method for hexagon. It's actually a little bit easier. What I'm saying is, to make a hexagon, when you make a hexagon, you use the radius, and you just start at a point on the circle, and you're making six different lengths. So I'm going to go from my starting place, stake it, lean it, arc it. Go to the next one, stake it, lean it, arc it. And what I'm pointing out here is you make 6 equally spaced vertices for the hexagon here. And Kim, if I wanted to make the equilateral triangle, right, I could use this same method, because here are 6 equally spaced arcs. But if I wanted to make an equilateral triangle, I could do this same method, and I could make my triangle. So if you feel really comfortable with this one, the equilateral triangle has a couple parts in the other way that you do it. So if this makes more sense just to skip everyone and make your equilateral triangle, that'd be great. But otherwise, we were asked to make a hexagon, so I'm going to do the correct answer and process for this problem is actually just what I'm doing now. It's just to make a hexagon. What I'm trying to point out is how they're related. Okay. So don't worry. If you're like, I didn't make the triangle, do I have to go back and upload my paper? No. Did you learn something here? You see? Triangle skips. Hexagon just goes to every point. And again, I'm just using my radius. And I'm going to, from a point that I decide, and I went around and made equal tick marks all the way around. And what's cool about a hexagon is that's just based on the radius. You didn't have to change it. Okay. So we have radius AB. You could even note that. You can note that from the center to the outside of the circle. You could say that this is AB. But that's not necessary either. They were just giving you the measurement to start with, and labeling it as extra. They didn't say you had to label. Okay, well then let's see what number 8 was. Oh, 8's the exact same thing. So it'll give you a chance to see it one more time. It says, using it says to make it with a radius of CD. So let's just say this is CD. So remember, I measured CD using the distance between my compass. I make one point, and to just copy a segment, from that point, just make a little arc here, put a line, a point anywhere on the arc. And what you've just created is you've copied the segment. So remember, you can open it. If I needed to copy this length right here, I would open it to this length, right? I would make a point to start, and I would make a arc over here, and then just connect. Okay. So it's all a matter of using this as a measuring tool. So this right here is the same. Whoa, that's a bummer. Is the same as I have to sharpen my pencil here real quick. As the same as that equilateral triangle side. I'm gonna just do it. Okay, so my compass pencil broke here. It may not work, but let's see. All right, let's go and make our radius. Boom. There's different ways you can make a hexagon, but this is the easiest way. There's my radius. I'm gonna go ahead and put my point here. And again, it's the method we're using. Ooh, almost. I thought I was on the track. I was like gonna say that's a perfect circle. That's not bad. And I could choose wherever I want to make this hexagon. I choose that point to start with, and look what I'm doing. I'm even gonna go the opposite way, which I never do. Opposite way around the circle. Okay. So this, if you like this method, and it's kind of fun because it's not fun, but you know, math fun, because you go around and you see if you get right back to where you started. And that's pretty good. I did. All right. So now I can go in and I can say, well, here are my points. Here are my vertices for my six-sided shape. It's a regular hexagon because those are equally spaced, which gives me equal sides. And there we go. And I could show that they're all the same by putting tick marks there. And I could do that here too. 1, 2, 1, 2, 1, 2. And just because it's on the same page, I don't want to confuse this. And I would make this 3. So then the segments that have 3 tick marks are all congruent. 2 tick marks, those are all congruent. 1 tick mark, those are all congruent. They're going to be different lengths just because we use different radius to measure it. Okay, any more questions in this lesson? Anyone want to see one of the earlier problems? That's just doing a triangle. How about I just do one just in case somebody needs to see it? How about that? I'll just do it. Why not? Okay, let's do number 2. Equilateral triangle. Yeah, I'll do 2. Perfect timing. I'll do 2. We just have to make an equilateral triangle, okay, with radius AB. So I'm just going to make a fictitious radius. This is AB, okay? Again, that's arbitrary. It doesn't matter if it is exactly the same. We're just practicing this. So if you don't have the workbook, just measure it quickly and don't waste time on that. Don't waste time on, well, it's not perfect. It's not about, nobody is going to go back and match that. We are learning the process, right? So see when it's important to be perfect and save for those moments. Don't make everything perfect. Otherwise, you just exhaust yourself. Okay. And that's not like doing it half-assed. That's doing it more perfect when you need to and not worrying about it when you don't. Okay. It's like a key. That's a key. It's conservation of energy. All right, look, here we go. What I'm going to do is I'm going to put, this is how we make an equilateral triangle. Okay. I'm going to put a point anywhere I want. I'm going to go to that point, keeping the same radius. See how it's the same radius? I haven't done anything yet. I'm going to go ahead and make an arc. It should go through the center. And then what we have now are these 2 points equal distant from each other and from this point that we started with. Now, what we need to do now is thinking about the definition of an equilateral triangle. The definition is that the sides are all the same. Equilateral. You see how that's the distance between the 2 vertices here? And essentially, it's one side of my triangle. To find the other side of the triangle and vertice, I just have to go and make a little mark showing that same distance that I just measured, right? But up to the 3rd side up here. Now that is my intersection point, which now I can connect. Whoa, barely fits. Wow, that's close. That's good. And let's go ahead and just put tick marks. All right. I think that's great. I'm going to stop the video because that goes over all the problems, and that should allow us to get everything we need from this homework assignment. All right, 10 minutes.